Hello, my name is Hala Abdul Jabbar. I am a student at Organic Chemistry 3 at 263 with Dr. D. My presentation is about the aspirin magic in human bodies. Let's get started. In my presentation, I will start by questioning who didn't hear about aspirin in everyday life. Its chemical name is acetylsalicylic acid, which is one of the most common synthesized medicine. The molecular formula of it, which is C9H8O4, and the molecular weight is 180 Dalton, and is considered as NSAID, which is the non-steroid anti-inflammation drugs. To start with, aspirin was discovered in 1897 by Flixhofen. Who's Flixhofen? He's a German chemist working for a Bayer company who was able to modify salicylic acid to create acetylsalicylic acid, which was named aspirin by then. Why aspirin? Aspirin is considered as one of the class of the non-prescribed medication that is also called salicylates, which is used to reduce fever and to relieve mild to moderate pain from headache, arthritis, toothache, period, and muscle ache. Also, aspirin can use to prevent heart attack in people who have had a heart attack in the past or who have like a chest pain that occur when the heart does not get enough oxygen. Also, additionally, it used to reduce the risk of death in people who are experiencing or have already experienced a heart attack and a stroke that have been made by blood clot that blocks the flow of blood to the brain. Yeah. Next, you might wonder how to make this amazing drug. In chapter 18 this quarter, we went through the aspirin synthesis. As we know a lot about aspirin, this is the time to think about the organic chemistry of making it. However, aspirin is one of the most synthesized drugs, as I have mentioned before, and me personally have synthesized aspirin years ago in the lab. The first process of making aspirin is the step involving the addition of the organic compound salicylic acid that is shown here, which is like also responsible for the anti-inflammation action of the medication aspirin, and mixing it with the liquid acetic anhydride, which is in the reaction called acetylation. This reaction forms acetylsalicylic acid, which is the chemical name for aspirin that we can see here. And as shown, like as I circle like these two groups, which are like exchange, forming aspirin and acetic acid as a side product. Let's move forward. And what is the NMR spectroscopy? Maybe you are wondering, what does that mean? It's an abbreviation for nuclear magnetic resonance spectroscopy. The nuclear magnetic resonance is an analytic chemistry technique used in quality control. The NMR instrument allows the molecular structure of a material to be analyzed by observing and measuring the interaction of a nuclear spin when placed in a powerful magnetic field. It's used for quality control and research to determine the content, purity, and the molecular structure of any compound. Talking about aspirin, as we can see here, that is the HNMR of aspirin. And to start with, aspirin contains aliphatic, aromatic, and a carboxylic acid proton that spin a wide range of a hydrogen spectrum. The methyl group that is shown here on carbon number 1, it appeared as uncoupled singlet. at 2.36 ppm due to the inductive deshielding on the oxygen side of the acetoxy functional group. Moving forward, aromatic proton appears in the series of multiplet, which shows here as carbon number 6, 7, and 8, and 9, which are these carbons. Moving forward, the carboxylic acid substituent is moderately deactivating and drawing electron density away from the conjugated pi system of the carbon number 9, which is the ortho, and carbon number 7, which is the para, position via inductive effect, causing the carbon 9 proton to shift downfield to 8.05 ppm, while, as we can see here, while the carbon 7 proton appeared to be centered at 7.53, as mentioned here and as you can see here. The carboxylic acid resonance peak 13, which is like the last one, identified to be like the most downfield chemical shift as on 1177. Moving forward, what does IR mean? Infrared spectroscopy is the analysis of the infrared light interacting with the molecule. This can be analyzed in 3 ways: by measuring absorption, emission, and reflection. It is also used to study and identify chemical substances or functional group in a solid, liquid, or gas form. IR spec measures the vibration of atom, and like as we know naturally, the bonds stretch and compress with a certain vibration frequency. So like these typical measured in wave number, which are expressed in inverse centimeter. Especially talking about aspirin, as we can see on the 3000, it's the showing the OH stretch following Y by the 2600, it is the CH bond, then the CO double bond of an ester, then the CO double bond of the carboxylic acid, following with the CC double bond of the aromatic ring, and finally the CO single bond at 1190. Now, how aspirin work? Aspirin is one of these medications that gets like rapidly absorbed in the stomach, and it works by how does it work? It works by blocking the production of messenger molecule, which is like as shown like here, which is like act as like an on and off switch that regulate pain, inflammation, among other things. So aspirin inhibits the activity of the enzyme called cyclooxygenesis, which lead to the formation of some molecule that cause inflammation, pain, and fever. So that inhibition is of the enzyme, which is like prevent like this medication, as like shown here by the mechanism. So like this aspirin is getting acetylates the hydroxyl group of the serine residue, the 530, causing the inhibiting of like this enzyme and converting the aspirin back to salicylic acid by like removing this acetyl group to here and the hydroxyl group. So this aspirin is converting back, inhibiting this enzyme. As also shown here, like this is the aspirin, this is the serine, and that's the final product. Additionally, in addition to the chemical blocking, aspirin also reduces the risk of the heart attack and stroke. It can do that by prevent the platelets in the blood from clumping and clotting in the arteries, and reducing the risk of heart attack. So like aspirin works on platelet by stopping that clotting action, since blood clots block the artery. It do, as we can see here, it inhibits the platelet production and aggression, which result in bleeding. And the aspirin inhibits this platelet by irreversible acetylation of the serine residue again, which is like you can see like this difference here and here. So this one is get acetylated and this one is not. So this enzyme is getting stopped and stops their production of the platelets, and prevents like the clots and allowing the blood to move easily. And here is the resources, and thank you for listening.